Welcome again to the best learning channel worldwide. Simplified RSA is the name of the institution, and making it looks easy is what we do. It's been a minute, right? But I'm back again by popular demand. And I have some awesome stuff that I need to share, but I always have something to share. It's just that sometimes I would be busy and I won't have time to like put out a video out there. So, um, the most common mistake that teachers make, um, that would be, but I don't blame them, of course, because you have a class that is an average of 25 students, 30 students, or even 40 students in South Africa. And uh, you have to present a topic to the students. Suppose the example topic would be equations of motions in physics, right? So we all know how the equations of motions looks like. And then the teacher will go ahead, break down the equations, trying to explain to make it make sense to the student. But what we forget is that students view the equations in their own way, individually. And I've realized that there are some common mistakes that students do, or that makes them to look at the equations and see the equations as foreign, because there are some things in the equations that we don't mention. Like, for instance, when we look at the equations of motions, the first equations, it is final velocity, initial velocity, acceleration, and change in time. But the problem starts when we talk about that change in time, which is what I've picked up. Hence, in my world of teaching, like whenever I get an opportunity to share some knowledge with a student, I allow the students to express themselves. Hence, I have this phrase that I say that you have all the rights to be wrong, because I want them to be wrong confidently, so because you get to see how they view a certain expression, a certain equation, or a certain mathematical whatever situation it may be. So now, um, the most common mistake that I've picked up lately, and it's a common mistake that is applied by most students. When students look at the equations of motions, and then they see that in all those equations of motions, somehow there is a triangle. That triangle, some students believe the triangle is a variable of some sort that needs to have a value as well. The triangle, we call the triangle delta in physics or in the scientific um, world, because it's a Greek letter that represents change. So students tend to believe that the triangle plays a role of variables, just like your velocity, your acceleration, your time. So they believe that triangle probably should have a value of its own, or even not like that, but they tend to believe that, like, not necessarily believing even, let me say, they view the change as a foreign concept of a variable which they think it may mean something. And mind you, I interact with a lot of intelligent students. One smart student once even asked me that, sir, is that triangle next to the T, is it an isosceles triangle or an equilateral triangle? And that was that was a fun mathematical joke, to be honest. So she wanted to know if it matters the shape of the triangle. Is it a right angle triangle? Is it an isosceles triangle? Referring to delta, of course, of which that clearly shows that the understanding of these things, the investment is there, but somehow we might have failed to explain what delta is for the student at an earlier grade. Or it could have been when, by the moment the teachers were explaining what delta is at previous grades, like grade 7 or grade 6. I'm not sure where it begins like that, but it could have been that probably the student might have not been ready at that point, or it could have been that at that moment there was no enough attention that was paid, or it could be just you forget, right? So I want us to talk about delta today. I want to explain what delta means such that not even for a single time will you ever confuse delta as a variable. So let's go. This is what delta means. So delta is a Greek symbol. Is a Greek symbol that is used delta is a Greek symbol that is used to represent change or difference in a quantity. So that triangle, it doesn't represent, unlike acceleration, velocity, time, and displacement, which is position. That triangle represents the change or the difference in quantity of something. It doesn't necessarily play a role of a given variable, such that, let me think of position. So when we say change in X, we are talking about change in position. Change in position how? For anything to get to whatever destination it is destined to, it must initially start somewhere. If we look at the number line, a number line has 0, 1, 2, 3, 4, 5, 6, 7. If I look at the number line like this, if I was to look at this number line as a scale of position, which would be in meters, so 0 meter, 1 meter, 2 meter, 3 meter. If a person moves from 2 meters and they move to 5 meters, we say they have covered a distance of, so it's 0, 1, 2, 3. They have covered a distance of 3 meters. Hence, we say the change in distance is the initial displacement minus the final displacement. Don't worry about me mixing distance and displacement. They mean more or less the same thing. It's just that the other one is a vector and the other one is a scalar. So displacement is when we look at it in terms of a scalar. That's when we care about the direction. So it would be to the right as well. But when I say distance, we don't really consider the direction, whatever movement. So now, this is what the change, I want to explain the change now. That change that is happening when a person moves from 2 meters to 5 meters, initially they were on 2 meters, and then the final distance they are on 5 meters. So the initial distance they are on 2 meters, the final distance they are on 5 meters. That's when we say the change in distance is equals to the final distance minus the initial distance. So change in distance represents the final distance subtracting the initial distance. Therefore, that's when we will have 5 minus 2. And 5 minus 2 will give us 3 meters. Hence, the person that traveled from from 2 meters to 5 meters, they traveled a distance of 3 meters. That's how we represent the change in distance from the first position to the next position. So the delta, which represents change, just a Greek symbol, it doesn't play a role. It's not triangle multiplied by x. No, it's just change in position. So the triangle represents change. That's just like when you are solving for an expression, sometimes we use therefore in the form of dots that creates a triangle. So therefore, it can be considered the very same similar way that we use delta. Delta just represent change. It doesn't play a role on the variable itself. I hope it makes sense. Okay, furthermore, let's have another example. Suppose we have change in velocity. This represents change in velocity. And we know that velocity now, suppose our number line represents velocity and the SI unit for velocity is meters per second. So suppose a car accelerates. Oh, no. Suppose a car moves from rest. Suppose a car moves from rest and then it catches up to a velocity of 3 meters per second. So we say the car initially it was at rest. When it was at rest, rest means it is not moving. So the velocity is 0. And then the car starts to move and then it maintains a velocity of 3 meters per second. So then if we had to calculate velocity, we would know that this is our initial velocity, meaning initially the car was not moving, it was at 0. And then the final velocity that it maintained, the final velocity now became 3 meters per second. And then if I am to represent the change in velocity in the form of calculation, I will say change in velocity is equals to final velocity minus the initial velocity. It is always final minus initial. Whether you have a positive increase, I mean, like whether it is going to the right such that it's 0, 1, 2, 3, or it is decreasing, it's always final minus initial. Even if you get a negative value, it is understandable because you are talking about vectors. Vectors have directions, either positive direction or negative direction, whereby negative direction represents the opposite direction. So don't worry about that. But whenever you are calculating change is always going to be final minus initial. So the final velocity would be 3 minus the initial velocity would be 0. Therefore, we say the average. We say the change in velocity is 3 meters per second. So change meaning change or difference of, it doesn't really play a role. Hence now, if now you get to a scenario where you say acceleration is equals to change in velocity over the change in time, you don't necessarily have to think of the triangle having to matter like that. It does matters, but what this means, it means that V of final velocity minus initial velocity over final time minus initial time. So you will be able to substitute each and every variable like that. That's what change means. That's what this triangle means. This triangle means that you just have to distribute this like that. That's what change is for. I hope it makes sense. So confidence comes when you are sure of what you are doing, when you understand exactly the approach that you're going to take. Now, back to the equations of motions. When you look at these equations of motions, you must know that you have all the variables, but then the triangle doesn't really play a role in the form of a variable. It just means you have to express the change of those variables. So for change in t, it would be t final minus t initial, but it will end up being one value because when you take one value, subtract the other one, you're only going to have one value. So even if you are given that a car traveled for 2 minutes, if a car travels for 2 minutes, we know that initially it was at 0 minute and then it went to 2 minutes. So the change in time is 2 minutes minus 0 minutes, just like that. So the change is just there to express the change. And to be honest, every variable or every equations that you see, it comes from another existing equation in most cases. Like, let me give you an example. Let's look at the first equation of our equation of motions. the first equation, VF is equals to VI plus A change in T. Final velocity is equals to the initial velocity plus acceleration change in time. Let me show you something. So suppose confidently you know that acceleration is equals to change in velocity over the change in time, right? And you know at this point that change in velocity represents final velocity minus initial velocity, right? Now, it means where there's change in velocity, I can substitute final velocity minus initial velocity because it's the same as change in velocity. So I then say acceleration is equals to final velocity minus initial velocity all over change in t. And now, if I decide to make VF subject of the formula, obviously I will cross multiply because we know that any number is over 1. So meaning I will multiply the acceleration with the change in time, and then I'll multiply the final and initial velocity with the 1, such that this will result in VF minus initial velocity is equals to acceleration times change in time. You see, because I multiplied the acceleration and the change in time, so it will result in this. If I take the initial velocity to the other side, I would have that final velocity is equals to initial velocity. It will change a negative sign and becomes a positive plus a change in t. And then there you go. You have your first equation of motion that was derived from something that you know already. So all these equations of motions, they are not foreign. They are coming from exactly the information that you already know. It's just that the mathematics behind led for us to have this. So from here, I could have expressed T as TF minus TI, but clearly it means as I left it for that point, I know that this triangle, which is delta, it doesn't play so much role. It just represents that I will get my time in a form of change. So I strongly believe that this information can boost someone's confidence out there to look at the physics equations in a different way. Just know that the triangle, it doesn't really penetrate into being part of the equations like that in the form of a variable that you have to substitute for a specific value. No, the triangle just represents change, meaning before and after for that variable that is at the back of. Thank you for watching. This is Simplified RSA. We are the guys who makes it look easy. Please subscribe to our YouTube channel and feel free to contact us to inquire about our private lessons. We offer private lessons at a very reasonable fee. Here is our contact. You can send us a WhatsApp or an email.